The Sun is responsible for everything in our solar system. It is the reason why Earth has thriving ecosystems. The life cycle of a star is one of the most tragic events in the universe. The life cycle of a star depends on its mass. If the star has more mass, its life will be cut short. If the star was of much less mass, like our Sun, its lifespan will be much greater. The star's mass is determined by the amount of matter in the star nursery, also known as a nebula. Over time, hydrogen is brought together by gravity. Eventually the ball of hot hydrogen will begin to spin faster and faster. When the temperature reaches 15 million degrees, nuclear fusion will begin. The cloud of gas, which is called a protostar, would begin to glow brightly and become stable. This part of the star's life is called main sequence. The Sun is currently a main sequence star. It will shift to the next stage in about 5 billion years. The main sequence star converts hydrogen to helium in its core. Eventually the supply of hydrogen will run short and the star will start to stop generating heat. The core will become unstable and get a lot denser. The outer shell of the star will begin to expand. As the star cools down, it will start to glow red. This is the red giant stage. This is the beginning of the end for the star. The red giant will start to rapidly destabilize. The core will start to collapse and the outer shell is blown apart. This is a supernova explosion. If the star is of low mass, the core will remain as a white dwarf. However, if the star is of higher mass and it undergoes a supernova explosion, there is a chance it will become a neutron star. This is the second most dense thing in the universe next to black holes. If the core of a red giant is about 3 times the mass of our own Sun, something else will happen. The core is so unstable that it would be swallowed by its own gravity, forming a black hole. If the star collapses into a black hole, then not much happens after that. The black hole will go on to ravage other stars or planets. If the star becomes a white dwarf, it will stay like this for a very long time. It will let off a little bit of heat and light. The white dwarf clings to life for about 10 billion years until it eventually fizzles out forever, becoming a black dwarf, which lets off no heat or light. One night in 1604, the astronomer Johannes Kepler looked up into the night sky and spotted a strange new star. He thought that he had witnessed the birth of a star. He wrote the book De Stella Nova about the new star. Kepler's star was visible for 18 months before the star vanished. We later know that this is in fact the death of a star. Supernovae are extremely bright. They are so bright that they don't have a unit. The brightness can rival the galactic center. Betelgeuse is a red supergiant that we can see in the sky without any equipment. Betelgeuse is due to explode within the next 100,000 years. The supernova will be so bright, it will be seen during the day. This several billion-year journey is what has made us possible. Without the matter that is ejected during a supernova, planets wouldn't exist, comets, asteroids and life couldn't exist without the death of a star.